Today we'll be exploring the concept of scientific notation. This concept is closely tied with significant figures, also known as sigfigs. And if that sounds unfamiliar to you, I recommend you go watch our previous videos on the rules of significant figures and how to do equations with them. Essentially, scientific notation is an alternative way to convert a number's total amount of significant figures by either adding or removing their sigfigs. Now, this really comes in handy when multiplying or dividing numbers, since we can change our product or result to the right amount of sigfigs, allowing us to more easily follow the laws of significant figures. There are 4 rules to scientific notation. The first rule says that the base should always be 10, and the base is this number over here, the 10 in blue. So that number is always 10, no matter what. The second rule says that the exponent must be a non-zero integer, positive or negative, but not 0. So this number over here in red should always be either negative, positive, 1, 2, 3, 5, negative 5, negative 2, but not the number 0. Rule number 3 says that the absolute value of the coefficient is greater than or equal to 1, but it should be less than 10. So that means that our range for the coefficient, which is the number in green, should always be between 1 and 10. However, it can also be the number 1 itself. So 8.39 respects this since it's between 1 and 10. Lastly, onto our fourth rule. The coefficients can be positive or negative numbers, including whole and decimal numbers. So we know that 8.39 is a decimal number since the decimal is in the middle of the number and not behind it, making it not a whole number like 10 or 5. So that's still okay though, since we know from rule 4 that the coefficient can be decimal, or it can be a whole number, so it could also be 8, or it could be negative 8, since negative numbers are also fine. Now, with the rules established, I'll give you a 3-step method to do scientific notation. Step 1 states to move the decimal point so that you have a number that is between 1 and 10. Step 2, count the number of decimal places moved in step 1. And lastly, step 3, write the amount of places moved above the base of 10 in the exponent place. So this sounds like a lot of gibberish, but if we have the example of, let's say, 150, which is a simple number. So what it's saying that to do scientific notation and turn it into this form over here with the times 10 to the 5, or any other number, since exponent is not always 5, it can be a different number, which will determine how in step 2. Then let's say we have the decimal place over here, which is 150, and we want to make this 1.5. Then we have to move the decimal place twice to the left, once and twice. Boom. Now it's 150. 1.5. Now it's 1.50 over here. In that case, our coefficient is between 1 and 10, and the 150 has been converted to a proper place in step 1. However, now we need to count the number of decimal places moved in step 1. So each bump represents a movement of 1. So there's one bump, which means we moved once, and there's another bump, which means we moved twice. So that's 2 movements in total. Now where we're going to put that number of 2 is in the exponent value. So our base is always 10, so we write times 10 and to the 2. However, we remember that in our fourth rule, we stated that the exponent can be either positive or negative. However, to determine if it's positive or negative, we need to look at which way we moved the decimal. So in 150, we moved it to the left. So we went from 150 to 1.5. So we moved this way, right? So that means in this rule, that left is equal to positive exponent. So we have to remember that. It's an important rule. So that means that the 2 stays as it is since it's already positive. However, if we wanted to go back from 1.50 into 150, then we would be moving the decimal to the right. So we would have 2 movements again, right? So one movement over here and a second movement putting the decimal place over here, which makes 150. However, the base is always 10 times 10 to the 2, However, now we're moving to the right, so we have to remember that the exponent is going to be negative. So we write -2. And that is the correct way to do scientific notation. The problem is done, and we have no more changes to do to it. And effectively, we achieved our goal. Also, it's important to note that the base and exponent do not count when checking for a final significant figure amount. So over here, this does not count when we count. We're only looking at the coefficient, since that's the number that we're converting. And the base and exponent simply represents how many times we moved. Now that you know how to do scientific notation, you can convert any number's total amount of significant figures into a different amount. This will help when doing equations in most scientific fields, including chemistry, physics, and biology, since you can now change the product of an equation into the correct amount of sigfigs, and thus you can do scientific notation.